Good morning, one and all. My name is Andur Gaurav from EC Department, Vignan Srinivila. Today we'll discuss the energy spectral density and its concepts. Therefore, the first topic related to this energy spectral density is first topic to this energy spectral density is the Rayleigh's Energies theorem. Rayleigh's Energies theorem. Let that Rayleigh's Energies theorem will be given as E is equal to integral of minus infinity to infinity mod of x of t whole square dt, which is equal to 1 by 2 pi from minus infinity to infinity mod of x of omega whole square d omega. This is the case, and which in some cases this can also be expressed in terms of frequency also. This was a statement which indicates that is the energy expression in time domain, and this was the energy expression in frequency domain. Therefore, when we start with the left hand side of this one, that's integral of minus infinity to infinity mod of x of t whole square dt, which is equal to minus infinity to infinity. This mod of x of t whole square can be written as x of t into x star of t dt. Then it is equal to minus infinity to infinity 1 by 2 pi from minus infinity to infinity, that's x of omega e power j omega t d omega. That's nothing but it is from the inverse Fourier transform expression. It is from the inverse Fourier transform expression and the x star of t dt. Therefore, change the order of the integration, that's 1 by 2 pi from minus infinity to infinity x of omega, keep it outside, and minus infinity to infinity x star of t, this one, and e power j omega t, then dt, then lastly the d omega. Now, for this particular integration, take the complex conjugate x of omega up to here the same. For this particular entire integration, take the complex conjugate, that's minus infinity to infinity x of t e power minus j omega t dt whole complex conjugate d omega. Therefore, this entire thing will be nothing but our Fourier transform, which will be equal to 1 by 2 pi minus infinity to infinity x of omega into x of omega whole star d omega. Again, these two will be written as 1 by 2 pi from minus infinity to infinity mod of x of omega whole square d omega. That's nothing but our RHS part. And this in turn can be defined as in another form by taking the omega is equal to 2 by f. Therefore, d omega is equal to 2 pi into df. Therefore, when we substitute that 1 by 2 pi minus infinity to infinity, we'll substitute mod of x of 2 pi f and whole square. Then d omega is 2 pi into df. This 2 pi gets cancelled, and our x of this 2 pi f can be represented as x of f. Therefore, this will become minus infinity to infinity mod of x of f whole square df. This is the another form of the energy expression. Energy in terms of frequency. in terms of the frequency. Next, if we consider one particular system like this, if we consider one particular system with the input as x of t and its Fourier transform as x of omega and the y of t whose Fourier transform as y of omega, therefore the impulse response as h of t, then its Fourier transform as h of omega. Then when we take the magnitude and squaring it, it will be like this. Here also magnitude and squaring it, it will be like this. Here also magnitude and squaring it. We know that from the magnitude we can get the energy of the input signal. This is the energy of input signal, which is equal to 1 by 2 pi from minus infinity to infinity, this mod of x of omega whole square d omega. What is this mod of x of omega is? It's nothing but it is the psi x of omega d omega. This is the energy expression. Similarly, the energy expression for the output Ey is equal to 1 by 2 pi from minus infinity to infinity. It has been psi y of omega d omega. And it is can also be given as 1 by 2 pi from minus infinity to infinity. This is mod of y of omega whole square. And this mod of y of omega whole square can be given as mod of h of omega whole square into mod of x of omega whole square. As from our relation between y of omega, h of omega and x of omega, which is equal to 1 by 2 pi minus infinity to infinity. This one is as it is mod of h of omega whole square, and this one is psi x of omega. Therefore, this will becomes our energy expression, the energy of the output. Energy of the output. It's been called as an energy of the output signal. This was from the mod of x of omega whole square we'll get the ex. From the mod of y of omega whole square we'll get the ey. That's the case. It can also be given by like this particular form, 1 by 2 pi from minus infinity to infinity psi y of omega d omega. In terms of input, it is ex is equal to 1 by 2 pi from minus infinity to infinity psi x of omega d omega.